In this question, you can see there are four resistors, R1, R2, R3, and R4. This circuit, as you can see, it is a combination of both series and parallel connection. Now, there are two parts for the question. First part is to find the total resistance or equivalent resistance of the circuit, and the second part is to find the current in each resistor. So we'll solve the first part of the question. So in the first part, they're asking to find the equivalent resistance. To find the equivalent resistance, as I told you, circuit is a combination of both series and parallel. So first we'll solve the parallel part of the circuit. So you can see all the resistors R2, R3, and R4 are connected between A and B. So you can find the total resistance between the points A and B. Total resistance in parallel is equal to 1 by R2 plus 1 by R3 plus 1 by R4. So 1 by Rp is equal to R2 value is equal to 15 ohm. R3 value is also 15 ohm. And R4 is 30. So 1 by Rp is equal to 2 times 1 time, which is equal to what? 5 by 30. So this is the value of 1 by Rp. Rp will be the reciprocal of this, 30 by 5, which is equal to 6 ohm. What's the meaning of it? The meaning here is you can replace all the resistors between R2, all the resistors R2, R3, and R4 by a 6 ohm resistance. That is, the resistance between A and B, you can replace it by a 6 ohm resistance now. So I have replaced all the resistors between A and B by a 6 ohm resistance now. R1 value is 4 ohm. Now you can find the total resistance of the circuit. You can see this 4 ohm and 6 ohm are connected in series. So total resistance is equal to 4 plus 6, which is equal to 10 ohm. So the first part of the question is over now. In the second part, they are asking to find current in each resistor. To find the current in each resistor, first we'll find what is the total current in the circuit. So total current in the circuit will be equal to, total current is equal to total voltage applied in the circuit divided by total resistance of the circuit. In this case, you can see total voltage applied here is given as 10 volt. Total resistance is also 10. So current in the circuit is 1 ampere. So 1 ampere of current is passing through the circuit. Through R1, the current is 1 ampere. At the point A, the current I1 is dividing, that is 1 ampere is dividing into 3. So we need to find the value of I2, I3, and I4. Again, the current becomes 1 ampere here. So to find the current I2, I3, and I4, we need to find what is the voltage across AB. So voltage across AB you can find if you know what is the voltage across R1. So first we'll see what is the voltage across R1. Voltage across R1 is, we name it as V1. V1 is equal to I1 into R1. I1 value is 1. R1 value is 4. So voltage across R1 is equal to 4 volt. So once you know what is the voltage across R1, you can find what is the voltage across AB. So total voltage in the circuit is the sum of voltage across R1 plus voltage across AB. That means you can find voltage across AB is equal to total voltage in the circuit minus voltage across R1. That is 10 minus 4, which is equal to 6 volt. So once you know the voltage across AB, you can find the current I2, I3, and I4. So first we can find the current I2, then you can find the current I3, then I4. So I2 is equal to VAB by R2, which is equal to 6 divided by 15, which is equal to 2 by 5 ampere. Similarly, the value of I3 is VAB by R3, which is once again 6 by 15, which is equal to 2 by 5 ampere. Now, the last current is what? I3. I3 is last current is I4. I4 is equal to VAB by R4, which is equal to 6 divided by 30, which is equal to 1 by 5 ampere. Now, how do we confirm the answer? To confirm the answer, we add all the current, I2, I3, and I4. So when you add all the current, 2 by 5 plus 2 by 5 plus 1 by 5, which is equal to 1 ampere. In this way, we can solve this question.